Hi, Bobby. So, looks like you and Janakiraman had some interesting sessions where you learnt a lot.
Yes, we did some experiments.
That's right. So, looks like you had a very interesting introduction to, charging, voltage, current, power, and so on.
Yeah,
And I noticed that you actually took apart several interesting electronic
correct.
instruments.
phone.
Cell phone, correct. I saw that. So, very interesting. So, I think you looked at different parts of the cell phone, right? The camera, the display, and so on. Battery, correct. That's right. And you learned more about the battery. So, maybe today we'll start looking at, since you started, looking at some analysis of current and voltage in the battery, I thought we could discuss, what voltage is, what current is.
More formally what it is.
Understood. Right? So, maybe we'll start from there. So, I was thinking it will be good to give an analogy. So, maybe what is the simplest way that we can teach, because electrical engineering is somewhat abstract, because nobody can think of a charge.
I cannot see it.
I cannot see it. I can only feel its effect. So, what is a good way to understand it?
Analogies
is a good idea.
Yes.
Okay. So, maybe for voltage we will think of it this way. We will go back to some very simple example in mechanics.
Sure.
So, let us think of gravitation. I like gravity a lot, right? It is something which everybody can feel.
Yes.
Right. So, let us think of gravity, right? So, you have the ground, and at some height, let us say there is some point 1, and at some other height there is some point 2. I am going to take two different heights.
Okay.
Right. This is at height h2, this is at height h1. Okay. So, now we know that at any point on the surface of the earth or around the earth, there is a gravitational field with, there is a gravitational constant small g, right? Any mass, physical mass that you place anywhere in the earth's gravitational field is going to experience a force.
Yes.
Right. And I think in high school physics we learnt about this as potential energy. Right, when you have a mass at a height.
Correct.
So, I am going to, because voltage is also called potential difference, I am going to build an analogy based on this. Right.
Yeah.
So, what I am going to say is, because there is a concept of potential energy, we will think of a mass m being taken, let us say from point 1 to point 2. Okay. And I am going to say that I want to find out how much energy I need to give the mass to take it from point 1 to point 2.
So, I am doing some work.
You are doing some work, right? So, you need to give some energy. So, you need to do some work to take it from point 1 to point 2, because I am assuming that this height is larger. So, I am moving from a lower height to higher height, right? So, I think we all know, I need to give it, so I will call it the energy difference, right? The energy difference between the two states, the position 1 and position 2, is the amount of energy, the amount of work I will need to do. That is, we know from mechanics, that is simply the mass times this gravitational constant times the difference between the two heights.
Okay. Yeah.
Right?
Yes.
I want to bring in a similar analogy.
For the potential difference.
For the electrical potential difference. Actually, this is gravitational potential difference.
Correct.
This is also one kind of potential difference.
Yes.
Right? So, I am going to say we want to build in the concept of an electrical potential difference. So, just like we assume, when we do mechanics, we assume that this gravitational constant is constant wherever you go on the surface of the earth, and independent of the height, we assume that g is constant. Just like that, and uniform.
Okay.
So, just like that, I am going to think of a concept of a uniform electric field. I am going to call that electric field E.
Okay.
Right? Physicists tend to think of a gravitational field. Now, I am thinking of an electric field.
Okay.
Okay. So, I am going to think of an electric field in this direction, downward direction.
Okay.
Just like the G was downward. And I am going to take 2 points, 1 and 2. Okay. And I'm just like you had a mass in mechanics. Now I need to think of something, which
Charge.
experience. Yes, charge. Great.
Okay.
So we'll think of a charge Q.
Okay.
Okay. And we will imagine that you want to move the charge just like that situation. We will say you want to move it from point 1 to point 2.
Very similar.
Very similar.
Okay.
Right. And now it turns out that from basic physics, you can show that you need to do work.
Sure.
Just like you have to do work, you need to do work to take a charge Q from point 1 to point 2. Because we have drawn it such that point 2 is, the electric field point is downwards from point 2 to point 1. So you will have to do work to do this. And what is that energy difference? So energy difference in this case happens to be the charge times the potential difference. So
between those 2 points.
Between those 2 points.
Okay.
So now you imagine a potential difference between these 2 points.
Okay. Okay.
So now there is a definition that the potential at every point is with reference to some infinity. But now we don't want to bring that abstract concept here.
Correct.
We will just think of potential difference. We don't need to know about infinity and so on. We will just say you have 2 points. This is the potential difference. So I will say that this is the potential electrical potential difference.
Okay.
Okay.
So the potential at 1 can be even 0.
It can even be 0.
Okay.
In fact, you will, as we learn more, we will find out that the common way of doing things, just like here, you had the surface of the earth.
Okay.
Once the point reaches that point, once the mass reaches here, it doesn't move anymore.
Sure.
Right?
Yeah.
You can think of that as the reference height
Okay.
with which you take the height. Same way, we think of something called ground,
Okay.
electrical ground, which is at 0 potential.
Okay. Okay.
So there is the concept of earth potential or ground potential.
So that will make the analysis life easy, I guess.
That will make it a lot easier because this becomes, if you take V1 as ground potential, this just becomes 0.
Okay.
Okay. Then you only need to think of a voltage.
Yeah.
So Q times V2.
Yeah.
Right. So imagine you need to take it from 2 to ground. Then it is just energy difference is just Q times V2. It is very simple. So now we have managed to give at least some analogy instead of making it completely abstract.
It's very easy to
Very easy
relate.
to
Yeah.
relate.